All right, so now we're on to chapter 4. We finished all of our chapter 3. And once again, we'll be working with linear functions. So a lot of you guys, I think, will be pros for this lesson. Our 4 objectives are being able to find the slope, being able to graph functions using slope and intercept, aka slope-intercept form, also known as our y is equal to mx plus b. We're going to be able to graph and interpret applications of slope-intercept from like a word problem standpoint. And then we'll be able to use the slopes to identify whether lines are parallel or perpendicular to one another. And so to foreshadow this last objective, all parallel lines, this is my short script for parallel, have the same slope. Famous fact. Whereas all perpendicular lines, this is the short script for perpendicular, upside down, capital letter T, to represent right angles, right? All perpendicular lines form right angles. I guess learned that from your geometry class. Well, all perpendicular lines also have what's known as negative reciprocal slopes. And so an example of that is like, let's say your slope was 1/4. The negative reciprocal is reciprocal is just you flip your numerator and denominator. So now it's 4/1, and negative means you just multiply it by a negative. So negative 4/1, which is the same as just -4. We have some definitions. Linear function is a function whose graph is a line. Linear functions can be written in that mx plus b format. Or from a function notation perspective, f of x is equal to mx plus b. B is your y-intercept. M represents your slope. Remember, definition of y-intercept is when x is equal to 0. X equals 0. And your slope is your rise over your run. Definition, delta y over delta x, which is y2 minus y1 over x2 minus x1. We'll be dealing with constant slopes, meaning that there is no slope. It doesn't go up or down. Positive slopes, it's like you're running up a hill, or negative slopes, you're skiing down a mountain. And so, yeah, this is just more formalized slide of slopes, what I just briefly said on the previous page: rise over run, delta y over delta x, y2 minus y1 over x2 minus x1, and finding slopes, the step-by-step procedure. But we'll practice it with this example 1. So you read the graph left to right. Notice that you're skiing down a mountain. So our slope is going to be what? Yep. And so the easiest way to identify slope when you're looking at it graphically is you find where it hits the corner of a square. in two different spots. So here, and then here's another location. And so how do we get from one purple dot to the next? We're gonna go down 2 units, and then we're running across 3, right? 1 square, 2 square, 3 square. It's a different color. And then 1, 2. So down 2, -2 over 3. This is our slope. If you're confused at that method, you can also just find the coordinate points of these two and then use change in y over change in x. This coordinate point is 0, 5. This coordinate point is 3, 3. So we have change in y, 3 minus 5 over change in x, 3 minus 0, -2 over 3.
We can do it like the opposite way. Like over 2.
3 over 2 is not the same as 2 over 3. Yeah. It's always rise over run. You can put the negative opposite. So 2 over -3 is the same as -2 over 3, but you don't want to run first and then go up or down. You always want to do up or down first and then left or right. Yeah. Up or down is always your numerator. Left and right is always your denominator. And this slide is just more formal definitions. Know that all horizontal lines are y is equal to some number, whereas all vertical lines, which aren't functions, are x is equal to some number. And then again, left to right, going up a hill, positive slope. Going down a hill or skiing down a mountain, negative slope. Straight horizontal line, 0 slope. Vertical line, undefined slope, aka not a function. So now we're asked to find slopes of these lines. Oh, x equals, is it a horizontal or a vertical line? Vertical line. All vertical lines have undefined slope. Y equals is horizontal or vertical? All horizontal lines have 0 slope. Also known as a constant slope. Example 3. So now we're going to practice using the whole delta y over delta x, because now we don't have it visually. We are just given our first xy coordinate point and our second xy coordinate point. So difference between your y values all over the difference between your x. We have 4 minus -3 all over -7 minus -2. Two negatives next to each other equals positive. So we have 4 plus 3 over -7 plus 2, which gives us +7 all over -5. And this is the same as just -7 over 5. Either way, you would get full credit. I just personally like the negative in the numerator. And you're done. Our second objective is using the slope and its intercept. So y is equal to mx plus b. And we're very comfortable with finding slope now. It's now, okay, what's our b value? Remember, y-intercept when x is equal to 0. That's our famous definition. When x equals 0. Then we get our b value. So we want to identify the slope and y-intercept of these two lines. First one, it's in the famous y equals mx plus b format. So very easily we can identify both our slope as well as our y-intercept. Our slope is what? Yep. And our y-intercept. Part B, we have to put it into y equals mx plus b, so we have that additional step. And then we can identify what our slope is. So we have to isolate that y. Let's go ahead and subtract x from both sides. And so we're given 3y is equal to negative x plus 9. Then let's divide 3 on both sides. So we get y is equal to negative x over 3 is the same as negative 1x over 3, which is the same as negative 1/3 x. And then 9 divided by 3 is just 3. So now we can very easily identify what our slope and what our y-intercept are. Our slope is just negative 1/3, and our y-intercept is just positive 3. That's it. Questions at all? How are you guys feeling on this topic so far? Good? Yeah, it's a fun one. So let's do some more practice. Example 5, we have a function and we want to graph it using its slope and y-intercept. So again, y equals mx plus b. Identify your slope and identify your y-intercept. What's your slope here? Negative 1. What's your y-intercept? 4. So how do we graph this? Always, when you're graphing, you always want to graph y-intercept first. So plot y-intercept first. And then use your slope, aka your rise over run, to plot a few more points to connect the dots. Right. So 4 for your y-intercept. As a coordinate, that's 0, 4. And then we're going down 1/1 for your slope each time. Connect the dots, and then you're done. Don't forget to write the equation of your function as well. So our objective 3 is graphing and interpreting applications of slope-intercept. So maybe I'll have someone read the yellow, another person can read the purple, and then the last person can read the pink. So who wants to be yellow? Thank you.
Many real-world applications are modeled by linear equations. We'll take a look at a few applications here so you can see how equations written in slope-intercept form relate to real-world situations.
Purple. Thank you.
Usually when a linear equation uses real-world data, different letters are used for the variables instead of only using X and Y. The variable names remind us of what quantities are being measured.
Good. And then pink.
So we often will extend the axis and angular coordinate systems to figure positive and negative numbers. So yeah.
Nice. Well done. I feel like the purple and pink are very hard to distinguish on the screen. It's much easier to distinguish on mine. All right. So let's do example 6, going back to the whole Fahrenheit and Celsius. We have 4 parts. We want to find the Fahrenheit for a Celsius temperature of 0, and then find the Fahrenheit for a Celsius temperature of 20. Then we want to interpret this, and then we're going to graph. So we can solve the first 2, maybe even 3 on this one, and then graphing I'll put on this second slide. So part A, find the Fahrenheit for a Celsius temperature of 0, aka we're just plugging in 0 wherever we see a C. And so 9 fits times 0 shoots to 0. So we end up getting that when we have 0 degrees Celsius, our Fahrenheit is 32 degrees. Sort of interpreting as we go along. Now we want to find it when C equals 20. So wherever you see a C, we're now putting in 20. 9 fits times 20. It's the same as 20 divided by 5 times 9, which is just 4 times 9, which gives us 36. And 36 plus 32 gives us 68, right? So that tells us that when we have 20 degrees Celsius, that's the same as it being 68 degrees Fahrenheit. And now it says interpret the slope and f-intercept of the equation. So our slope here is equal to 9 fits. And our f-intercept, aka our y-intercept, is equal to 32. And so to interpret this, the f-intercept, this tells us that at 0 degrees Celsius, we are equal to 32 degrees Fahrenheit. Whereas the slope tells us that for every Celsius increase, our Fahrenheit is increasing by 9 fits. My pen stopped working. So for every Celsius degree increase, Fahrenheit increases by 9 fifths of a degree. And then last but not least, we're asked to graph it. So our 9 fifths C plus 32. Gonna do this one on the next slide. So again, we have C is equal to 9 fifths F. Is that correct? Oh, sorry. F of C equals 9 fifths C plus 32. I'm going to get rid of this scale. And then we'll go up by maybe fives. 5, 10, 15, 20, 25, 30. So that 0, when C is 0, then we have 32, which is here. And then let's do when C is 5, then we have 9 plus 32, which is 41. Two, three. And we can do, should we do 10? Let's do 10. So then 18 plus, so that should give you 50. 45, 50, and then that's 10. So we're looking at something like this. And then we're done. Few more slides and then we're there. So we have the cost of running some types of businesses has 2 components, a fixed cost and a variable cost. Fixed cost is always the same regardless of how many units are produced. This is the cost of rent, insurance, equipment, advertising, and other items that must be paid regularly, aka our y-intercept. But the variable cost, which is our slope, that depends on the number of units. So it's for the material or labor needed to produce each item. So now let's look at example 7, where we have Sam drives a delivery van. We're given this function, C of M is equal to 0.5 M plus 60, where C represents our cost in dollars and M is the miles he drives. And we want to find Sam's cost for a week when he drives 0 miles. So what is C of 0? Plug in 0. 0.5 times 0 cancels out. And so we just get $60. What about when he drives 250 miles? Then we have C of 250. Well, 0.5 times 250 is just half of 250. Which gives you 125. And then you add 60 to that. And so you get $185. We want to interpret the slope and the c-intercept of the equation. So the slope tells us, right, our slope is 1/2. And then our c-intercept is 60. Which tells us 0 miles driven, your base is 60. 0 miles still costs you $60. That's your initial cost, initial fee. And then for every additional mile, it's going to cost you $2. So each mile, $2 more. Shouldn't say each mile is $2. It's 1/2. So every mile is 50 cents more. Each mile is 50 cents more. And then finally, we're asked to graph it. And so maybe I'll put the graph on the next page once again. 0.5 m plus 60. So C of m equals 0.5 m plus 60, which is just 1/2 m plus 60. Again, I'm gonna go up by 5s here. So 5, 10. I don't know why I did that. I should go up by 10s. So 60, and then we're gonna go up 1 over 2. Up 1 over 2. Up 1 over 2. It's gonna be going really, really slowly. Right. Kind of like this. And then we're done. So this is the last part for today. I do want to finish it up, so just give me a few more minutes and I promise I'll be done. But this is exactly what I said before. Parallel lines have the same slope, whereas perpendicular lines have negative reciprocal slopes. Okay. So let's just practice a few examples highlighting that. We want to find the equation of a perpendicular line to this equation. So if our slope is 3 here, our negative reciprocal slope is just negative 1/3. And then it passes through this point. So this is where we should use what's known as our point slope formula. Which is y minus y1 is equal to mx minus x1. And this is your x, and this is your y, your x1, y1. So you just plug in all of the information, and I'll color code, right? This is going to be our slope here. This is going to be our x1, and then this is going to be our y1. So we end up getting y minus 0 is equal to negative 1/3 x minus 3. Can you simplify? Yeah, this is just the same as negative 1/3 x minus 3. But either any of these equations that I have written in black down below, you would yield you full credit. The last one is the most simplified by far, but either of these, unless they explicitly state put into slope intercept, you could use any of these and get full credit. Because that last one is what's in slope intercept form. We'll do 2 more examples and then we're done. So our example 9 is now finding a line parallel. Remember, parallel lines have the same slope. So if our slope is 3 here, our parallel slope is also 3. And then we utilize that same formula. Y minus y1 equals m in parentheses x minus x1. Y minus 0 equals 3, x minus 3. That's a possible answer. Y equals 3 in parentheses. X minus 3 is another answer. Or distributive property, and we get 3x minus 9. So any of these would suffice. And then finally, we have our last example for today, which is our example 10, where we're going to be utilizing the whole change in y over change in x. 5 minus 6 over 4 minus negative 2 in order to get our slope to be negative 1 over 6. And it says find the equation of a perpendicular line that passes through the point. So if this is your slope of the regular, your perpendicular is negative reciprocal, which is 6 over 1. And then passes through the point. Once again, use your point slope formula. Y minus 5 is equal to 6 in parentheses, x minus 4. And again, you can keep it in point slope unless they explicitly state to put it into slope intercept. But yeah. So that concludes this section.